Hello everyone, hope you all are fit and fine. So today we are going to discuss another important and interesting question on the linked list, that is odd even linked list. So in this question we are provided with the linked list and we need to modify that linked list in such a way that all those nodes which have the odd data will come at the very beginning of the linked list and all those nodes which have the even data will come at the very end of the linked list. Okay, and we need to perform this operation in order of one space complexity, order of n time complexity. Now, moving to the second point is that we that while solving this question, you need to maintain the order of the nodes. Means if one is encountered before the 7 in the provided linked list, then also even the resultant linked list one need to be encountered before the 7. Third point about this question is that don't forget to update the head and the tail pointers at the end. Just because here you can see we are calling the addFirst and addLast to check whether you have successfully updated the head and the tail pointers. So it's my request you pause this video right now, try to solve it by yourself, and after that we will discuss its solution. So I hope you have solved it by yourself. Let's try to implement it. So we know here we are provided with a linked list. Let me create it. I am assuming that I'm provided with a linked list like 1, 2, 4, 5, 6, 8, and 10. Okay. So what will be my approach to solve this question is I'm going to use the same approach which I used in the previous question, that was remove duplicates in a sorted linked list. If you have not watched that video, then the link of that video is in the description box. You can watch it. Okay. So what will be my approach is I will create here two new linked lists, that is the old linked list, even linked list. I will keep on iterating over the provided linked list, keep on removing the first node from the provided linked list and add it to the newly created linked list based on some condition. What will be those condition? Let's figure it out. Okay, the first thing is that iteration over the provided linked list, remove the first node, add it to the created linked list. So I am adding it to the the odd linked list. Okay, again keep on removing over the keep on iterating over the provided linked list, remove the first node, add it to the newly created list. So newly created list, so I am adding it to the even list. Okay, so again iterating over the linked list, removing the first node, adding it to the even list. So I think you get the intuition behind this question. So the intuition behind this question is that keep on iterating over the provided linked list, keep on removing the first node from the linked list and check whether that node data is even or odd. If that node data is even, then add it to the even linked list, and if that node data is odd, then add it to the odd linked list. Okay, so let's complete the dry run of this question. So here it is 5, I removed it, I add it to the odd. Here it is 6, I removed it, I add it to the even. So here it is 8, it is even, I add it here. Here it is 10, which is even, I add it to the even. Okay, you can see at the end the this will be pointing to null, just because the linked list that it was pointing to is now deleted, means it is now empty just because we have deleted all of its nodes, and at last we get odd and even linked list. So what we'll do, we will add both of these linked lists in such a way that odd linked list will be at first, and we will map the tail of the old linked list to the head of the even linked list, so that it get connected and we get only a single linked list and as the required linked list. One more thing you can see here is that all of our nodes order is maintained successfully. Like even in the provided linked list, 2 is coming arriving before 4. So here you can see even the resultant linked list 2 is arriving before 2. Okay, so the last thing is that which I need to do here is that I will update that this properties with the odd and even linked list properties. Okay, so let's try to code it and then we will check its time complexity. Okay, so we are going to code on the Pepcoding portal. So here the first thing what we'll do is we'll create a linked list. So we create the linked list with the name odd, capital L, linked list, and the other will be even linked. linked list. Okay, so one more thing which I want to tell you, which you some of you are thinking, is that some might be thinking that why aren't we working on the nodes, like why, like we don't use the concept of the tweaking of the nodes. We are not using it just because in this way all the smaller details, like what happened when the size will be 1, what happened when the size will be 0, setting of the head, setting of the tails, all those smaller details are already maintained in the linked list class functions. Okay, we don't want this clutter in our code. That's why we use this concept. The only thing that matters at the last is whether we have learned something, whether we are learning the concept under the prescribed space time constant and the space constant and the time constant or not, and we are learning it. So now it doesn't make any sense that we write the see that we make the same clutter in our code and make our code more complicated for the reader. Okay, so as we have already created a higher level of abstraction, that's why we don't use all these things of the tweaking of the nodes in our functions here. Okay, so we use the functions which are provided as a template code. I hope you get it. So let's complete this code. So our next step is iterating over the linked list, provided linked list. So we write a loop while this dot size is greater than 0. We keep on iterating over the loop. We keep on removing the first node. Before removing, let me get the data. This dot get first. Sorry. Now let me remove that node. This dot remove first. Now I need to add that remove node into my newly created node, that either in the even linked list, either in the odd linked list, and I will add it to those linked lists based on some conditions. So I will check if that node which I have removed at even data 2 equals to 0, then I will add it to here, else I will add it to the odd linked list. Okay, odd dot add last. addLast is also of order of 1 time complexity, we know that. Okay, we know it is of order of 1 time complexity. Similarly here, if it is even, if it was even data, we add it to the even linked list. We know that it is also order of 1 time complexity. Okay, so till now we have iterated over the linked list with which we are provided with. Now the linked list is empty, means we have already we have removed all of its node. All those nodes come either into the odd linked list or come either into the even linked list. So what we do at the end, we need to update the properties of the this pointer, and we need to add both the odd linked list and the even linked list in such a way that all the odd data come at first, all the even data come at last. So one case that arises here is that what will be the situation that when the linked list with which I am provided with have only the odd data, and what will be the situation that when the linked list with which I am provided with have only the even data. So what I'll do in that case, let's figure it out. If I'm using the normal case, if the linked list I'm provided with have both the odd and the even data, let's complete that at first. If odd dot size is greater than 0 and even dot size is greater than 0, I'm using the normal case at first. So if my linked list have both the odd data and the even data, so what I'll do, I will map the tail of the odd linked list to the head of the even linked list. So odd dot tail, sorry, here odd dot tail dot next will be nothing but even dot head. Okay, now what I'll do, I will update these properties. This dot head will be nothing but odd dot head, and this tail dot next, yeah, this dot tail will be nothing but even dot tail, just because odd and even are not connected into a single linked list. Okay, even dot tail, and this dot size will be nothing but odd dot size plus even dot size. Now let's figure out the another case. what happen if the linked list with which I was provided with have only the odd data? It means odd linked list have all those nodes now, and even linked list does not have any node. So it means even linked list size is less than equals to 0. Okay, let me write like that. So if this is the case, what I'll do, I will update, I will not uh, map the tail of the odd node, odd link, the tail of the odd linked list with anything. I will just update the properties of the this. So this dot head will start mapping to the head dot, sorry, odd dot head. This dot tail get updated with the odd dot tail. This dot size get updated with odd dot size. Okay. Else let's figure out that case when only the linked list with which we are provided with have only the even data. In that case, we don't map even linked list with anything. We just update the properties of this pointer with the even linked list properties. This dot head will be nothing but even dot head. Sorry. So this dot size will be nothing but even dot size, and this dot tail will be nothing but even dot tail. Okay, let's try to run it. O dot size, O dot, let's try to run it and check whether it has any error or not. It is accepted. Let's try to submit it. Okay, okay, yeah, it is accepted. Answer is correct. So let's try to understand how it time complexity will be order of n and order of 1 space complexity. So the first thing which I want to is the first thing is that we have created a new linked list. At first we are trying to understand the space time complexity. Okay, so here you can see I'm iterating over the provided linked list. Okay, provided linked list, I'm assuming that it has an element, so it will be nothing but order of n. Okay, here I'm not performing any other iteration. Here I am just doing the updations, so it is just order of 1 time complexity operations. So I can see that my time complexity is order of n. I think you can see it. Okay, now let's try to understand the space complexity. Space complexity, you might be thinking that I have created here two nodes, two linked lists, odd and even. But what if I will tell you that I have not created any linked list, I have just created the objects of the linked list class. Okay, as you can see, linked list is a class and I have created two new objects, that is odd and even. Okay, so what will be the memory that these objects are holding? Just because odd have the three properties, it is holding the size of the head, tail and the size. Similarly, even has three properties: head, tail and size. So if I'm assuming that each of properties are taking 4 bytes, then it is nothing but of the 12 byte. Similarly, it is nothing of the 12 byte. But here you can see, but here you will say that we are adding the nodes in the even linked list and the odd linked list. But what if I say that we are not adding, we are not copying the nodes, we are just at first removing the nodes from the provided linked list, and then we are adding to the either in the odd or even. Means a single node cannot exist in more than one linked list at a certain point of time. Means a node can either exist in the provided linked list, either exist in the odd linked list, or either exist in the even linked list. That means the space that was provided at the very beginning of this code is same as the space provided at the very end of the code. Just because we have changed the links, we have not created the new space. Okay, I hope you get it. So that's all for this video. I hope you get it, that how this solution is of order of 1 space complexity. Like we have not created any other space except these two nodes, these two objects actually. And I hope you get it, that how it is of order of 1 order of n time complexity. I hope you get it, that why are we using such type of functions, get first, why are not we working on the tweaking of the nodes. That's all for this video. If you like this video, don't forget to hit the like button, subscribe our YouTube channel and share this video. Till then, stay safe, stay healthy.